This training will cover fire and smoke dampers and actuators and their applications, the codes and standards that are used with fire and smoke dampers, the periodic maintenance that is required and recommended, and the differences between fire and smoke dampers and actuators and ones used for HVAC control. And we'll wrap up with the Honeywell fire and smoke actuator portfolio. Fire dampers are used to maintain building codes and fire resistance ratings when ductwork penetrates walls, partitions, and floors. In the event of a fire, a fusible link melts at a temperature high enough to indicate fire. Often these will melt at 165 degrees Fahrenheit, and when they do, the damper will close. Fire dampers are designed to prevent the passage of flame from one side of a fire-rated partition to another. Although the dampers are used in the ductwork, they are securely attached to the wall with breakaway connections so that if the ductwork falls away, the dampers will remain and maintain the integrity of the wall or floor. They are also used to isolate large air handling units. Fire dampers may be rated as static. These are used in systems where the HVAC system is shut down in the event of a fire. Or they may be rated as dynamic, where the HVAC system will operate during a fire. Fire dampers can be either a curtain type or a multiple blade type. The curtain type has a metal curtain that is held up by a fusible link that melts in a fire and allows the curtain to drop. The multiple blade type damper looks more like a traditional HVAC control damper with blades and an actuator. These are powered open and spring closed. When the fusible link melts in a fire, it opens a circuit which allows the actuator to spring close. Other times they are triggered electrically, such as by our fire alarm system. Fire dampers in the U.S. must meet the UL Underwriter Laboratories 555 rating. There are two ratings, one for 1.5 and one for 3 hours, to comply with the different types of fire resistance ratings used in buildings. They must close and stop the flame from spreading for this long. Dampers in dynamic systems will also have an airflow velocity and pressure differential rating. And this test is performed with airflow in either direction through the damper. Smoke dampers are used in buildings to prevent smoke from moving from the source to other parts of the building. Like fire dampers, they are found where ductwork penetrates a rated wall or floor. Smoke dampers also can be static or dynamic. Static systems operate with the HVAC blower off. They are powered open and spring closed when triggered by a smoke detector or fire alarm system. Dynamic smoke dampers are part of what is called an engineered smoke control system and operate with the HVAC blower running. In these systems, the smoke dampers may be opened or closed during an emergency. They operate along with the HVAC blower and the outdoor air and exhaust dampers to exhaust and depressurize the smoky area while pressurizing the smoke-free areas to inhibit smoke infiltration. Smoke dampers in the U.S. must meet the UL 555S rating. Like the UL 555 rating, dynamic dampers will also have an airflow velocity and pressure differential rating. UL 555S smoke dampers also have leakage ratings. The actuator must also be able to operate the damper at elevated temperatures and be tested to 20,000 actuator cycles. Smoke dampers are rated to 250 or 350 degrees Fahrenheit. Combination fire and smoke dampers function as a fire damper and a smoke damper. They meet UL requirements for both applications, so they are used in buildings where both of these ratings are required in a given location. They close when high heat is sensed or when smoke is detected. They are usually manufactured with bimetallic sensors rather than fusible links. These switches are resettable and open the circuit when a certain high temperature is reached, typically 165 degrees Fahrenheit. And they may have a secondary switch that opens at 250 degrees. When these actuators are used in smoke damper applications, they're usually controlled by smoke detectors or fire alarms. Often they are wired to a fire control system where they can be remotely operated as well. Like single-purpose dampers, they may be manufactured for static or dynamic systems, and they may be round or rectangular. The actuator may be electric or pneumatic and must be installed onto the damper by the manufacturer, where the entire unit is tested to pass the UL tests. Field replacement of the actuator is permitted with a like-for-like replacement or a technically superior one. Although fusible links were commonly used on fire dampers in the US in the past, they have been largely replaced by electric dampers, as is common in Europe. These fire and smoke actuators are similar to conventional control actuators. Both can be driven to hold the damper open and will spring return closed when the power is removed. However, there are significant differences. The most important difference is UL certification. Most fire and smoke actuators sold in the US are UL rated for both UL 555 for fire applications and UL 555S for smoke. These combined fire and smoke actuators must be able to operate at 250 or 350 degrees Fahrenheit. Because of this, all components are metal, unlike control actuators, which may have some plastic components. Most electric fire and smoke actuators are 24 volt or line volt, spring return actuators that hold the damper in the open position when powered. And they can stay in this powered open position for a prolonged period. When power is cut, they spring close in a certain amount of time. UL specifies 75 seconds, and the International Building Code specifies 15 seconds. Because of this, most fire and smoke actuators close in 15 seconds. This is much quicker than a typical control damper. Fire and smoke dampers must be installed in accordance with the manufacturer's instructions. Correct installation includes things such as providing adequate space to access them. There must be doors that allow access to the inside of the ductwork to inspect and maintain the damper. Also, the damper must be identified with letters that are at least 1/2 inch in height. After installation, they must be periodically tested and maintained to ensure that they will function in an emergency. The National Fire Protection Association, NFPA, issues standards for installation, inspection, testing, and maintenance for fire and smoke dampers. These standards are used to create state and local codes. The International Fire Code also refers to NFPA standards. NFPA 105 covers smoke dampers. NFPA 80 covers fire dampers and combination fire and smoke dampers. There are other codes for special areas such as a large space or atrium. For more information and details about fire and smoke building standards, visit the NFPA and ICC, the International Council Code, websites, and also check local codes. I will cover the specific required maintenance in a moment, but the general requirements for fire and smoke dampers are that they must be tested and inspected when the system is commissioned, after it has been balanced, and 1 year after inspection. Then they need to be tested and inspected every 4 years, except in hospitals, where they need to be tested and inspected every 6 years. After fire and smoke dampers are installed and the system is balanced, an operational test needs to be conducted under normal HVAC airflow as well as with no airflow. Do this by making the damper automatically close and verify that it closes with no obstructions or interference that blocks complete closure. If it is a fire damper with a fusible link, then remove the link during the test and replace it when it is done. If it is a smoke damper system, the test is done with no airflow unless it is a dynamic one. Then the test needs to be done with airflow. During this test, verify that there is full and unobstructed access to the damper and its components, and that they are correctly labeled. In order to save time during inspection, motorized dampers can be operated remotely if the dampers are equipped with position indication such as end switches. Then the position can be monitored remotely, such as on a fire panel. However, they still do need to be physically observed for other steps of the inspection. Once done, document the test indicating the location of the damper, date of inspection, name of inspector, and any faults found. Keep this documentation accessible and be sure at least 2 people know where it is, so it can be found and shown if requested by an inspector. If any problems were found, they must be repaired without delay, and the repairs should be documented. After this repair, the damper must be retested. These same tests should be done 1 year after installation, and then every 4 years for most buildings and every 6 years for hospitals. Check with the local AHJ, the authority having jurisdiction, to learn more about local requirements for fire and smoke dampers in your area. Some codes require inspections every 6 months. Smoke dampers in atria and large spaces have special requirements per NFPA 92B. They should be tested at least semi-annually, and if there is standby power, these tests need to be conducted while using standby power. Smoke dampers that are part of a dedicated or non-dedicated smoke control system must also be checked semi-annually, and they should be operated for each control sequence in the design criteria. Additionally, whenever a building is remodeled or renovated, this is an opportunity for debris to enter the system. It is a good idea to perform a damper inspection after work is complete to ensure the system is ready for an emergency. If a fire and smoke actuator does not function, begin troubleshooting by checking that the appropriate power is being supplied to the actuator. This should drive the damper blades open. Also verify that the actuator is correctly mounted to the damper blade shaft so that the blades move when the actuator operates. If the blades touch the frame, verify that the frame is not racked. If the actuator does not drive open or drives open but will not spring close, replace the actuator. If the damper does not smoothly operate when the actuator is removed, the damper may need to be replaced. If it's determined the actuator has failed and needs to be replaced, select an equal or technically superior actuator that is UL 555 and UL 555S approved. These UL standards cover the manufacturing of fire and smoke dampers and actuators. They do not cover replacing actuators on existing dampers, other than to say it should be done in accordance with the damper manufacturer's normal field surfacing instructions. Local codes do address this issue, and usually a local inspector will allow a like-for-like replacement. Sometimes an older model of actuator may no longer be manufactured. In this case, a technically equal or superior actuator that is UL rated is usually accepted. The Honeywell document 38-00005, Fire and Smoke Damper Actuator Field Replacement Guide, covers actuator replacement and is available at customer.honeywell.com. That document, the Fire and Smoke Replacement Guide, includes a cross-reference from old Honeywell actuators, as well as competitive ones, to current models. Honeywell has two styles of combined fire and smoke actuators. One style has low or medium torque, and the other has high torque. Low and medium torque models have either 30 inch-pounds or 80 inch-pounds of torque. They are available with or without internal auxiliary switches. These switches, as well as the entire actuator, are designed to pass UL 555S requirements of 350 degrees for 30 minutes. They are fast operating with 15 seconds for both drive open and spring close. They fit onto 1/2 inch round shafts and are secured with 2 1/4 inch square drive set screws, so an Allen wrench is not necessary. Wiring is easy with lead wires for power and switches and clip-in conduit connections. One model can be used for clockwise or counterclockwise spring return. Just flip the actuator over for reverse action. This makes it easier to have the right actuator on the truck and reduces inventory. Here are the part numbers for the small and medium torque actuators. The MS stands for motor spring return. The next number is a 4, so it is line volt. It would have been an 8 for 24 volt. The 04 means it has 30 inch-pounds of torque. The 09 ones have 80 inch-pounds. The F means it is a fire and smoke actuator. And the 10 number in the last 4 numbers means it has no auxiliary switches. The 12 in the last 4 numbers means that it has 2 auxiliary switches. High torque models have 175 inch-pounds. Just like the lower torque models, they are available with or without internal auxiliary switches. They're designed to pass UL 555S requirements of 350 degrees for 30 minutes. They drive open and spring close in 15 seconds. The self-centering shaft adapter fits onto 1/2 to 1 inch round shafts and 1/2 to 3/4 inch square shafts, and it centers and tightens onto the shaft easily with one nut. The actuator has 1 meter long high-temperature lead wires and 2 integral conduit connectors. And just like the smaller actuators, each model can be used for clockwise and counterclockwise spring return. Just flip the actuator over for reverse action. Here are the part numbers for the high torque actuators. Just like with the smaller actuators, the MS stands for motor spring return. The next number is 4 for line volt and an 8 for 24 volt. The 20 is for 20 newton meters, which is 175 inch-pounds of torque. The F means it is a fire and smoke actuator. And when you see a 10 in the last 4 numbers, it means it has no auxiliary switches. And a 12 in the last 4 numbers means that it has 2 auxiliary switches. You can find more information on Honeywell's fire and smoke actuators at buildingcontrols.honeywell.com. Here you will find brochures, the Fire and Smoke Actuator Replacement Guide, and product specification and installation instructions. These are also available at customer.honeywell.com. There's also another video available at the Honeywell C-Pro channel on YouTube called Honeywell Fire and Smoke Actuators. For more information on fire and smoke dampers and periodic inspections, check with the manufacturer of the fire and smoke dampers you are working on, the UL and NFPA websites, and with the local authorities such as the fire marshal or inspector.